Well, good afternoon. I'm Carol Shaw. I'm with Wisconsin Department of Natural Resources. I'd like to invite you today to our final talk in this morning stretch on climate adaptation, case studies, and restoration at Spur Lake Natural Area. We have a couple of talks here this hour. The first one, I'm sorry, is on the restoration at Spur Lake Natural Area. And then we'll have a talk on flood resilience in the Coon Creek watershed about halfway through. So there are Q&As. I'm sure you've been part of the sessions this morning, so you can send your questions to the Q&A area. And if you want to vote on questions that are already up there, it'll kind of upvote them and make them the most likely questions to get answered if we're short on time. I also want to thank our sponsors this morning, Ontario Lake Management Planning Consultants. And if you have the opportunity, please visit their site during the event today and this week. So first we'll have the speaker on adaptation of restoration at Spur Lake Natural Area. Carly Lappin is a North Central Wisconsin regional ecologist for the Department of Natural Resources and our Bureau of Natural Heritage Conservation. And Carly, I'll just let you turn on your screen and have at it.
Sounds good. Thanks, Carol. Thanks for the introduction. Can you see my presentation?
Looks good.
Okay, great. So yes, as Carol said, we're going to talk today about a climate adaptation case study at Spur Lake State Natural Area. I'm going to give a little bit of background about the property and the lake, and then we'll talk about the actual adaptation project. So Spur Lake State Natural Area is located in eastern Oneida County. It is a shallow muck-bottomed lake. It's about 113 acres in size, and it supports dense beds of emergent, submergent, and floating-leaved aquatic plants. Historically, it supported significant wild rice populations. It was a culturally significant site. Local tribes harvested here regularly, and there were even rice camps known to have been held on the shores of the lake. Presently, it's a breeding site for black terns and also many other waterfowl species. The topographic map on the right here shows the actual property boundary of the state natural area with Spur Lake in the center. The lake itself is surrounded by good quality wetland communities, including open bogs and muskegs, poor fens, and black spruce, tamarack, and cedar swamp. It was designated in 2007 as a state natural area. And the outlet stream, Twin Lakes Creek, flows out of the eastern side of the lake. You can see it on the topo where my cursor is here. It flows to the east and then to the south where it joins the Pelican River and then the Wisconsin River. So it is part of the Wisconsin River watershed. Historically, as I said, this lake had a lot of wild rice on it. So these are pictures from throughout the years taken by Peter David of the Great Lakes Indian Fish and Wildlife Commission. You can see the density of wild rice on the lake. It was date regulated starting in 1964 when this practice was first established. And the rice was pretty reliably good within normal fluctuations throughout the years as far as anyone can remember. Starting in the early 2000s, wild rice began to decline on the lake. And as you can see in this photo from 2009, there's almost no rice on the lake itself. In around 1990, previous habitat managers noticed that perennial floating leaf plants were starting to increase on the lake. And over about a 15-year period, the extent of those dense lily pads had increased to cover most of the lake surface. Periodic good wild rice crops ended around 2003. So examining some of the probable causes of the wild rice decline, and a lot of these are exacerbated by climate change or are being exacerbated by climate change. Water levels are too high and too stable. So wild rice needs a water depths of 3 feet or less in order to be able to germinate and grow. Historically, the lake depth on Spur Lake had a maximum depth of about 3 feet, so it was ideal. But in 2010, a survey was conducted and the average lake depth was 3 feet. So a lot of the lake is too deep. There were some culvert adjustments made on the outlet stream in the 90s Those may have contributed to increased water levels on the lake, although we're not so sure about that. We do know that climate change is going to cause further threat to whatever potential wild rice might exist. Competition from floating leaf perennial plants is a major concern, and those are expected to do well with climate change due to milder winters with less lake ice and a longer growing season. In particular, white water lily is a very aggressive competitor that's expected to do well under climate change scenarios. It blocks light from reaching the water column and is also allelopathic. So, and that is what we're seeing good proliferation of on the lake. In addition, wild rice is very susceptible to climate change. It's a susceptible species and is sensitive to intense rain events during the growing season. Fast changes in water level during the floating leaf stage can uproot or drown plants. And it's also susceptible to warmer and more humid summers. So all in all, climate change is expected to produce even more detrimental effects on our wild rice at Spur Lake. So taking all of this into consideration, I was approached by the Northern Institute of Applied Climate Science and the Wisconsin Initiative on Climate Change Impacts to use some of the new climate adaptation strategies and workbooks that they have been putting together and host a climate adaptation workshop for Spur Lake State Natural Area. And this was intended originally to be a demonstration site for climate adaptation so that we could show what the results of a workshop look like and, kind of the outcome. So the framework of an adaptation workshop is to identify the location, ecosystems, and time frame of your site and establish partnerships, assess ecosystem vulnerabilities, compile adaptation strategies and approaches, plan and implement those approaches at appropriate scales, and then integrate monitoring and evaluate effectiveness. So our workshop was held in March of 2019 in Rhinelander with a number of interested partners. And we used the wetland adaptation menu and the draft tribal climate adaptation menu during our workshop. We looked at Spur Lake at its site level climate change vulnerability and brainstormed how climate-driven challenges and opportunities might impact management at the site. And then we identified actions to enhance Spur Lake's ability to adapt to changing conditions. So it was really an interesting workshop with a lot of different partners with different perspectives. We were able to brainstorm some really interesting tactics. So the partners that attended the meeting are represented on the bottom of the slide here. And this was a result of our workshop. We came up with a list of tactics with timeline and monitoring criteria. And climate adaptation itself is an effort in restoring natural communities to make them more resilient to climate change. So better able to come back or maintain in the face of climate change. Climate adaptation also involves accepting some changes, but steering management toward the better outcome of what you expect those changes to be. So we have a time frame on the left here and the different tactics that we identified during our meeting. And we'll go through some of these here. Some that have been implemented already is beaver control on the Twin Lakes Creek flowing out of Spur Lake, as well as setting up a monitoring program of the lake to understand what our management outcomes might be. Removing downstream vegetation also from Twin Lakes Creek. Collaborating on a seed bank study. Conducting a hydrologic study to understand the entire system and what some of the different focal points might be. And looking at some of the infrastructure downstream from the lake and examining how that might be improved. So all of these things we're going to talk about a little bit more in the next few slides, but really the overall goal of the Spur Lake Working Group, which is what another result of the workshop was, is we all compiled or kind of grouped together into a Spur Lake Working Group. The ultimate goal is to lower water levels on Spur Lake to evaluate the potential for wild rice production or wild rice restoration. So that's kind of what we're working toward at this point. So we're really focusing on these shorter time frame tactics to get started. So lake monitoring is important. It was really important to get that set up so that we have a baseline data to understand what sort of changes might result from our management strategies. And this involves several different facets, one of which is examining water levels, both surface and groundwater levels. The University of Minnesota has put water level sensors out on the lake now for the last 3 field seasons, which is what the graph here is showing. This is the 2019 data. We have precipitation in the blue line on the bottom, and then surface and groundwater levels on the red and black squiggly line. So this is, of the 3 years we've been monitoring, 2019 was the driest of the 3 years. And they're working on a report presently of that data. And they worked in partnership with Glyphwick to collect this data for us. We're also monitoring water quality and depth. That's being conducted by a citizen lake volunteer from our citizen lake volunteer program. And the Department of Natural Resources Lakes program is also has also established aquatic vegetation monitoring, which they conduct annually. Twin Lakes Creek itself has been affected by historic man-made alterations downstream, increased vegetation, beaver activity, and sedimentation. So the creek here, you can see, like I said, flows to the east and then to the south. And in this point down south of Spur Lake, looking at Lidar hillshade, you can see that there have been some alterations to the surface here that we think may have impacted Twin Lakes Creek. The creek itself is very low gradient and very saturated. It has been also further slowed by beaver activity, and all of this slowing of water movement has increased vegetation growth and sedimentation on the creek itself. So we think that there may have been some human-caused impacts that have slowed the flow of water out of Spur Lake on this system. Further kind of highlighting this is looking at some historic aerial photos. So 1938 on the left and 2010 on the right. You can see in 1938, there's a lot more woody vegetation in the basin, which would imply that it was drier at that time. So we've been looking a lot closer at this Twin Lakes Creek and what sort of efforts we can make to improve water movement. This is a Lidar analysis of the creek. So the red line shows different points along the creek that correspond to the x-axis of this graph. And what you're seeing in the black line here is the surface of Twin Lakes Creek as it travels downstream from Spur Lake to the bottom of the photo here, near where those man-made structures are that we looked at on the last photos. So you can see as you get down toward the end, there's a significant drop in water here, and this corresponds to like a man-made riffle that we identified on some private property downstream. So before we had even convened our adaptation workshop, we were focusing on restoring some of the water flow in Twin Lakes Creek. This was in 2018. We did a restoration project that widened the channel and also increased the depth of the channel to try and improve water movement out of Twin Lakes Creek. And this was the after photo, an aerial photo of the project site. We've also done a lot of work in the creek itself to remove obstructions and improve flow. Really, it's a huge wetland, so the only real way to do this is just manpower. We've hosted a number of work days with our Spur Lake Working Group partners where we all get out there and just get in the water, and we've been removing beaver dams and widening or removing vegetation in areas of the channel where it's really grown in, as well as just basic sedimentation. So you can see some before and after photos there of my coworker. The red dots on the map on the right are from 2019. Those were identified beaver dams that we removed over the course of a workday in July of 2019. Just this year, we received funding from the BRICO Fund through the Natural Resources Foundation of Wisconsin to conduct a hydraulic study. So we are going to be hiring a contractor to do that fieldwork for that this summer. It will include lake bathymetry, stream survey, tracer study, and water level data loggers. And the outcome of this will be analysis and modeling of current and possible future conditions. So we're trying to get a better understanding of what is happening within the system hydraulically, and then also hopefully identify sites or places where we can really focus our efforts to improve the movement of water and potentially lower water levels on the lake. So the outcome of this could also include recommendations for infrastructure improvements. That's kind of where we stand at this point. We are continuing to look for ways to lower water levels on Spur Lake, and this does include some infrastructure improvements. We've identified some culverts that we think could stand to be improved, and we'll be working toward that, I think, especially once the hydraulic study is done. So what's next then after that is we'd like to continue to use our adaptation strategy, that list of tactics, and update it as needed. We really do use that as like a baseline for the Spur Lake Working Group and our focus for that project. We would be interested in controlling perennial vegetation on the lake if we can get water levels down a little bit. And so that may involve mechanical, removement of perennial vegetation. And we're also looking at some evidence from Minnesota DNR where removing snow from the lake ice in winter has reduced perennial vegetation. We believe that's a result of colder temperatures reaching the bottom of the lake and freezing out some of the perennial species. So that's something that we'd like to look at and experiment with more when we have the opportunity and the funds, resources to do that. Ultimately, if we do get water levels down in the lake and can control some of the perennial vegetation, the next step would be wild rice restoration. So I did mention a seed bank study. Glyphwick and some of their interns conducted a seed bank study, and they weren't able to find any viable wild rice seed left in the lake. So the next question from there then would be, do we seed in wild rice, and what is the source? And that would involve quite a bit of consultation with our partners to identify if people are comfortable with that, and what the source of the rice seed might be, considering local genotypes and things like that. So that's kind of where we stand right now. It's been a really fun project. I've learned a lot and gained a lot of different perspectives from the working group and from our interested partners. And had it not been for the adaptation workshop, I don't think that we would have really gotten to this point. So it has been an interesting process for sure. And just trying to make Spur Lake more resilient and see, what our options might be to see if we can improve wild rice or bring it back to the site. So then I will open it up for questions.
Well, thanks, Carly. We have a few. What parameters are being monitored at the lake and creek? I know you mentioned just vegetation surveys, but.
We've got surface and ground water level monitoring, and we're also monitoring water chemistry and clarity and depth. That's with the citizen science or citizen lake volunteer, and then also point intercept surveys of lake vegetation. So we are monitoring lake vegetation to see how it might change, and keeping an eye out for aquatic invasive species as well.
Doesn't all this altering of the flow of water through the creek alter the natural evolution of the lake?
That's a good question. We have been looking very closely at Twin Lakes Creek and some of the historic aerial photos that we've seen, and we do think that the hydrology of Twin Lakes Creek itself had been altered in the past, and that may have contributed to changing water movement throughout the system. We're also in a very wet cycle right now, which has contributed to high water levels as well. So I think we're just trying to establish a system here that will set us up for, being able to succeed if water levels go down again, and either in a dry cycle or if we're able to improve water flow.
Okay. A couple people are interested in the Lidar surveys. How do they find out if they've been done on their water body?
I do not know the answer to that. A partner is the person who provided that data, so I wasn't actually involved with that sampling process.
Okay. How does it make sense to manually remove sediment in a low gradient outlet stream? Won't it silt back in within a year or two?
Yes, I believe that it probably will. I think what we're trying to do is improve the flow enough that it will scour somewhat and maintain that water movement, even though the sediment is still in the system. So we're trying, I think, to get to the point where the water is moving enough that that sedimentation will decrease.
Okay. A couple more real quick ones. Hopefully, what kind of permits were needed and how long did it take to get them?
The only permit that we've needed to secure thus far, it was for the stream restoration project, and that took a few months to obtain.
Okay. And could you tell us any more about the BRICO fund?
I don't know a whole lot about the BRICO fund. They worked through the Natural Resources Foundation of Wisconsin and actually approached us after having heard of the Spur Lake project. They were looking for some climate adaptation projects that they could provide funding for, and they are funding the hydraulic study.
Great. Well, I'm sure you could Google that name or something and people could find out about it. Well, thanks very much, Carly. We are
So-
about halfway through. We need to probably move to our next talk.